Okay, here is a kind of like a mini lesson that has to do with using patterns and formulas. So for Math 2, we have the following things going on. We have the difference of two squares, and we have perfect square trinomials. And we realized when we were doing them back in Math 2 that they went ahead and they followed a certain pattern. So let's go ahead and confirm these patterns just by doing them out algebraically. So let's start with the difference of two squares. So by using the claw technique or the FOIL technique, we get a times a, which is a squared, a times b, which is a times b, negative b times a, which is a negative ab, and then finally a negative b squared. So we can see from here that these two middle terms are going to cancel out, and we would have a squared minus b squared equals this guy right here. So that kind of shows that those are the same. So to use those, what we went ahead and looked at was when we were factoring the difference of squares, we could use this particular pattern. So let me make up a pattern here that has to do with a squared minus b squared. So if I had, for example, 4x squared minus 16, okay? So we could go ahead and write this as these two squared terms, 2x squared minus 4x squared. So using this pattern right here, we recognize that 2x was a and 4 was b. So we went ahead and we put these into this particular pattern here where we would say 2x minus 4, 2x plus 4 would be the factored version of this guy right here. And that's how we dealt with the difference of two squares in Math 2. And likewise, we saw perfect square trinomials. And to go ahead and show that these guys are equal to one another, we could go ahead and expand a plus b squared into a plus b times a plus b, and show that it's equal to that right there. So I have an a times a, which is a squared, plus a times b, which is ab, b times a, which again is like ab, and b times b, which is b squared, Cluck-like terms, and I get a squared plus 2ab plus b squared is equivalent to this guy right here that we said that it was. And we use that to go ahead and do shortcut to factoring in Math 2, such like the following. If I had a polynomial that was, let's go ahead and say 3x plus 4 squared, where I could go ahead and say that 3x was a and 4 was b. And then I could go ahead and replace those into what it equals, which was right up here. Okay? So let's go ahead and do that using the pattern. Is that this says that a plus b squared, which is a similar situation to this, is going to go ahead and equal to a squared, which is 3x squared, plus 2 times a, which is 3x, times b, which is 4. Oops. Let me get those parentheses in there. Plus b squared, which is 4 squared. So to undo this by pattern, we go ahead and we have this, which is going to put that exponent into each one of those terms, and that's going to give me 3 to the second, which is 9x squared, and then multiplying all those together, we got 2 times 3 times 4, which is going to give me 24x, and then 4 squared, which is 16. So I do know that these two are equal to one another by the pattern that we created in the general form of the perfect square trinomial.